Orbital Mechanics, it's two masses going around each other. That's all it is. It's relatively simple.
In our world, the key skill set is orbital mechanics. So you understand how things maneuver in space. I think you can pretty much understand what we do here.
We get to design trajectories to launch satellites into space.
So a trajectory is basically what you would call a flight plan. How we're going to get to the orbit that we want to be in.
We do range safety analyses, guidance accuracy analyses, different orbit types depending on customer requirements, and sometimes that involves determining what launch vehicle we need to use to meet the performance requirements. Pretty much everything involved in designing the mission from liftoff through spacecraft set.
We do everything to make sure that the rocket gets the payload into the right orbit.
Yeah, that's rocket science.
It's rocket science, but it's not impossible.
So at ULA, we have our own proprietary software that we use to help model our vehicles to very high fidelity. We have a series of simulations that we have on our shelf that we begin to tailor to be mission specific. We may go through optimization processes where we get them a better orbit every time we step through this process.
We want to make sure that when we get to orbit that we're not going to run into an active satellite or debris or the space station.
And then the trajectory people hand it over to us guidance folks. And what we do is then we turn that optimal trajectory into the software parameters that need to go onto the rocket itself to fly that profile.
Once those parameters are tested and proven ready to fly, and get those ready for launch. So on day of launch, everything is fully tested before flight.
Rockets, basically just a computer that has a lot of flame going at the back. We see how these things are going to fly probably hundreds or even thousands of times before we actually launch it. And then when we launch it, you watch that telemetry stream and you see just how close you got in your predictions.
Accuracy is paramount to what we do.
They can rely on us to get them exactly where they want to go. There's no concern that we're not going to get them in the place that they need to be.
A few high fives, a lot of handshakes. Our launch cadence here at ULA is so high, we're really thinking to the next one.
Activating your brain every single day is very fulfilling. It's never an easy job, but it's always a rewarding and fun to solve these kind of problems.
We have the capability to go outside of our solar system. That's huge to be able to come into work and be able to do that every day.
I like coming in every day and knowing that I'm going to be helping launch people to the space station.
Nothing beats that.
It's like GPS. We launch those things. And without that, I'd get lost on my way to work.
I'm Jeremy Ralph, and I'm a trajectory design engineer.
This is Matej Niedercic, and I'm a guidance engineer.
I am Mark Smith, and I'm a guidance and navigation engineer.
My name is Kurt Heyer, and I work in the mission design group.
I'm Caroline Kirk. I'm a trajectory engineer.
I'm James Runn. I'm the Vulcan trajectory focal at ULA.
That's what we do here at ULA. And to know that we're doing it with the best team in the world is pretty exciting.
I think that's about it.